Now that we know the definition of a function, let's use that definition to help us determine whether relations represent a function. All right. And so we have a couple of relations here, and then we're going to state the domain and range. Let's look at part A. Part A, we have x here with the values of 1, 2, 3, and y with values a, b, c, d, right? X gets sent to b, or corresponds to b, or gets assigned to b. 2 gets assigned to d, and 3 gets assigned to a. And so I want to know whether this is a function or not. Okay? Well, as long as each input gets assigned to one output, I can say it is a function, right? And so since that is the case here, this is a function. Okay, each input goes to one output. One, if I were to write this as a set of ordered pairs, 1 gets assigned to B, 2 gets assigned to D, and 3 gets assigned to A. That means my domain will include the values 1, 2, 3, and my range would include the values are the variables B, D, and A. And if you want to write that as A, B, D, that is fine. Okay. Part B. It says we have the values 1 and 2, and our y values, our corresponding y values are A, B, C, and D possibly. Well, 1 gets assigned to B, but 1 also gets assigned to D, right? Well, this fails that relationship or that definition that each input gets assigned to one and only one output, right? Here, our input 1 gets assigned to more than one output. So we would say that this is not a function. Okay? I'm not going to do the domain and range for this one since it's not a function. All right, let's go to C. All right, in part C, I have 4, 5. I have a set of ordered pairs here. I have the ordered pair 4, 5, the ordered pair 5, 5, and the ordered pair 5, 7. This would not be considered a function because of this here. 5 gets assigned to 5, and it also corresponds or gets assigned to 7. That fails the definition that each input gets assigned to one and only one output. So this is not a function. It is okay for 4. Now, if I just had, let's say I didn't have that, this would be considered a function because 4 gets assigned to 5 and 4 does not correspond or get assigned to any other thing, and 5 gets assigned to 5. Just because values are assigned to the same output does not mean it's not a function. As long as each input gets assigned to at most one output, then I would consider it a function. Okay, so keep that in mind. And so looking at this, notice I have -2 getting assigned to -2, and it also gets assigned to -1. Since -2 gets assigned to more than one thing, I know it's not a function. Okay, so you should be able to look at a diagram, look at a set of ordered pairs to determine if a relation is a function. And you should also be able to look at some equations to see if y can be represented as a function of x. All right. Y is a function of x. That means if I plug in an x, I should be able to get one and only one y value as the output. One and only one, right? At most one y value as the output. All right. And so here, one of the things that'll help me do this is to solve the equation for y. What I'm going to do, and whenever I'm given an equation and I want to determine if y is a function of x, is I'm going to solve the equation for y. Because when I solve it for y, so let's look at this. We have x squared, y cubed equals 1. I divide both sides by x squared, and I'm going to get y cubed equals 1 over x squared. I know this looks weird, but if I want to solve for y, I'm going to take the cube root of both sides. And since this is an odd index, I don't need a plus or minus here. So this is the cube root of 1 over x squared, or what you can write this as 1 over x to the 2/3, because cube root means the 1/3 exponent, and so 2 times 1/3 is 2/3, so I can write this as 1 over x to the 2/3. The reason why I write it like this, or writing it like this is helpful, is because if I plug in an x, I should try to plug in as many x's as possible. I plug in an x, raise it to the 2/3, and do 1 over that, I'm always going to get one output y value, right? And so since that is the case, I'm going to say yes, y is a function of x. Okay, let's go to part B here. All right, here I have x plus 2 absolute value of y equals 2. Again, I'm going to solve for y. The first thing I'm going to do is I'm going to subtract x from both sides. I have 2 absolute value of y equals 2 minus x, right? Subtract x from both sides. And then I've got to isolate this absolute value, so I'm going to divide both sides by 2. And so I get absolute value of y equals 2 minus x all over 2. Now, remember, we have an absolute value here, so we got to remember how to solve absolute value equations. In order for me to, remember, absolute value means distance from 0, so I want my distance from 0 to be 2 minus x over 2 units. Notice, remember, when we have our number line, there are 2 distances from 0, one to the left and one to the right, right? And so we drop the absolute value by setting what's in our absolute value equal to the positive of whatever we see over there, and we set our absolute value equal to the negative of whatever we see on our right hand side. And so since we get this case, when I plug in an x, I have to plug in an x here and an x here, do the calculation, and that's going to give me my output y. And so for a single input, like let's say I plug in 1 for x, right? I'm going to get a value for this equation, I'm going to get a value for that equation, and so when I input one thing, I'm going to get 2 values out. That means that this is not a function. Okay? Let's look at a graph to determine if y can be represented as a function of x. Okay, here I have this parabola, right? We'll be looking at relations that are parabolas throughout the chapter here. And so if I want to determine if y is a function of x, that means each x gets assigned to one y. That means if I look at some point here, some x value here, this is the corresponding point, I could only have one, for this x value, I can only have one y value here, right? I only have one y value here. There should not be another point with this same x value, but with a different y value, okay? No matter what points I pick on this function, each of them is going to have a separate x value, right? Every single point is going to have a different x value, different x value, different x value, different x value. And that means they have a different y value as well, okay? And they also have a different I'm sorry, they do not have a different y value. For instance, this point right here has an x value right there, and this point right here has an x value right there. They have the same y value, but as long as they have the same a different x value, we're fine. Let's look at this other example. If I pick this x value right here, for instance, this point looks like it has that x value. This point looks like it has that x value. If I were to write the ordered pair, that would be something like the point x, let's say 4, and I have the point, whatever the value of x is, negative 4, for instance, if this was drawing the scale and I picked the point correctly. Well, since they have the same input but a different output, it fails the definition of a function because not every x gets sent to one and only one output. This x value got sent to 2 separate outputs. All right, there is a test, right? So this is a function, and this is not a function. There is a test that allows us to kind of easily do this, and it's called the vertical line test. All right. When you're looking at a graph and you want to determine if y is a function of x, then what we can do is we can draw a vertical line. Okay. So if a vertical line can be drawn that passes through the graph of a relation at more than one point, kind of like in this example here. If I look at that vertical line, it crosses at this point and at that point right there. Then the graph is not a function. On the other hand, if you cannot find a vertical line such that if you plot it and it touches at more than one point, then you know that that graph is a function. No matter how many vertical lines I try to draw here, that vertical line is going to hit this function at one and only one point for every x value I can think of. And so that's why this is a function.